Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniela Trent here, and today we are going to work on some more practice problems that I collected from the IFM exam. This video will cover section 1-2, the core level. Alright, so let's look at the first problem. You're given the location of assets, portfolios 1, 2, 3, and 4 in the following capital market line diagram, where ER denotes the expected return and SDR denotes the standard deviation of the return of the portfolios. Which of the four portfolios are efficient? So here on the diagram we have the vertical axis representing the expected return, and the horizontal axis representing the standard deviation. We have two slant lines here, one downward and one is upward. The upward line is the capital market line, and we got four assets 1, 2, 3, and 4. Here it's very easy to recognize efficient portfolios. Wherever that lies on the capital market line is efficient, so have 1 and 2 are efficient portfolios, and 3 and 4 are non-efficient or inefficient. By the way, just want to recall that 1 is the risk-free assets, or we call RF, the risk-free assets with no risk. It's called risk-free assets because the variance and the standard deviation is 0. You see that it's right on the vertical line, so the standard deviation is 0. And the asset 2 on the capital market line is the market portfolio. And solution 1 and 2 are efficient portfolios. Problem 2. Which of the following statements are true? The variability of the market portfolio is the average variability of its individual component stocks. For a reasonably well diversified portfolio, only market risk matters. 3. The market portfolio consists of risk-free assets, and here multiple answers are acceptable. Here just look at the easy one to justify here is number 3. The market portfolio consists of risk-free assets. This is completely wrong because the market portfolio and the risk-free assets, even though they are both lie on the capital market line, but only the one that cross the vertical axis is a risk-free assets, and the rest are the market portfolio, so they are distinct. So number 3 is incorrect. Now let's look at number 1 and number 2 to justify. Well, number 1, the variety of the market portfolio is the average variabilities of its individual component stock. This is wrong. It is only true when these stocks are independent, leading to the covariance and the correlation coefficient are 0. But in general, we cannot say that the variability of the market portfolio is the average variability of its individual component stocks. So now we see 1 and 3 are both incorrect. Now let's look at number 2. For a reasonably well diversified portfolio, only market risk matters. Yes, only market risk matter. So number 2 is correct and 1 and 3 are incorrect. Alright, problem number 3. You are given the following information about 4 distinct portfolios. We got P, Q, R, and S with their expected return and volatility. Which 2 of the 4 given portfolios are not efficient? So we see here like Here, usually in order to justify whether a portfolio is efficient or not efficient, we look at the diagram, and whatever is on the capital market line is efficient, otherwise it's not efficient. But here we don't have the diagram. So here I want to introduce another way of thinking to recognize efficient. You can think that efficient means good, and usually for the investor, they expect high return and low risk. That means they want high expected return and low volatility. So we are going to compare these and then just eliminate the solution that are not efficient. So just look for identical number first. We see that here we got 5% for Q and 5% for R. We got 10% for P and 10% for Q. So we are going to compare between Q and R and P and Q, and we can eliminate the worst situation. Alright, so if you look at Q and R, you see they have the same expected return, but R has higher risk. You see R has volatility 15%, which means higher risk. So R is a bad choice. See that R is a bad choice. So R is not efficient. Now if we compare P and Q, they have the same volatility, but Q produce higher expected return. So P is the bad choice. So now we can eliminate P and R because both of them cannot be as good as Q. You see it? We cannot compare S with any of these because S has higher expected return but also higher risk. But there's no way to compare between S and these three portfolios. So we got Q and S are efficient and P and R are inefficient. So the solution is P and R, the portfolio that are not efficient. Now let's look at number 4. Which of the following statement is or true? It is possible to form a risk-free portfolio using X and Y if X and Y are perfectly positively correlated. Number 2, it is possible to form a risk-free portfolio using X and Y if X and Y are perfectly negatively correlated. Number 3, the efficient frontier is a straight line if X and Y are independent. Number 4, all of the above is true. Number 5, none of the above is true. So let's justify these statements one by one. The first one, it is possible to form a risk-free portfolio using X and Y if X and Y are perfectly positively correlated. So if they perfectly positively correlated, that means the correlation between them is -1. So we actually can cancel the term in the variance in the state innovation to have zero variance at the portfolio. For example, we can buy X and sell Y. Here X and Y are perfectly positively correlated. So rho XY is 1, right? So we are going to buy 1 and sell 1. We can either buy X and sell Y or buy Y and sell X. Just make sure we have to buy 1 and sell 1 so that we can produce a negative sign in it to cancel out some terms. And remember that sigma X and sigma Y are not equal. So here I assume that sigma X, which is the volatility of X, is A times sigma Y, where A is just real number, not necessarily to be whole number, not necessarily to be positive or negative, just a number. Maybe 0.3, maybe 1.6, maybe 1.7, whatever. For any number for any pair of numbers you can find this number A, right? Now I'm going to set a portfolio by buy 1X and sell AY. So the portfolio is P is equal to X minus AY. And now if I calculate the variance, I got variance of P is sigma square of X plus A squared sigma square of Y minus 2 A sigma X sigma Y. remember rho is 1. That's why I didn't mention rho in here, because rho is 1. The correlation coefficient between them is 1. And now we just have to simplify it to be sigma x minus a sigma y whole thing square. This is the formula of square of differences. And since sigma x is equal to a times sigma y, so this term is 0, right? That means variance of this portfolio is 0. So we already make a risk-free portfolio, right? We have we have formed a risk-free portfolio. Risk-free mean volatility is 0. That's it. Alright, so similar, if x and y are perfectly negatively correlated, that means rho of x and y is -1. We can also do the same thing, but we are going to have we can either buy both or sell both, but we're not gonna buy one and sell one because we already have a negative sign in it, right? So we do not have to produce another negative sign. So it's similar to 1. You just have to work it out. Instead of like buy one sell one, we just have to buy both or sell both. Number 3 is also correct. The efficient frontier is the straight line if x and y are independent. Yeah, when they are independent, then we're gonna have the efficient frontier is a straight line. And the correct answer here is 4 because all of these statements are correct. Alright, problem number 5. Which of the following is true with respect to an efficient portfolio in the mean variance portfolio theory? Number 1, all efficient portfolios have the same Sharpe ratio. Number 2, all efficient portfolios lie on the capital market line. Number 3, all efficient portfolios can be the combination of the market portfolio and the risk-free assets. Number 4, all efficient portfolios lie on the efficient frontier in the absence of the risk-free assets. Number 5, all of the above are true. Solution. So here let's justify these statements one by one. Look at number 1. All efficient portfolios have the same Sharpe ratio. This is true because all the efficient portfolio lies on the capital market line, and the capital market line have the slope, which is the Sharpe ratio. So all efficient portfolio have the same Sharpe ratio, which is just the slope of the trade line, the capital market line. So 1 is true. Number 2, all efficient portfolio lies on the capital market line. This is straightforward. It's just right at the definition of the capital market line. So 2 is true. Number 3, all efficient portfolio can be combination of the market portfolio and the risk-free asset. This is true. Remember that the capital market line is a trade line that crosses the vertical axis as a risk-free asset, and the other points on the capital market lines are the market portfolios. So all the efficient portfolio can be is actually the combination of the market portfolio and the risk-free assets. So 3 is true. Now number 4, all efficient portfolio lie on the efficient frontier in the absence of the risk-free asset. This is correct because the risk-free asset is also an efficient portfolio because that is where the capital market line crosses the vertical line, the vertical axis. So 4 is true. And 5, all of the above are true. This is correct. So the answer is number 5. All of the above is true. Alright, so that's it for today. Thanks so much for watching this video. This video is not does not have so many calculation. It's all about reading, comprehension, and understanding. It requires a lot of reading. Alright, thanks so much for watching. If you like this video, please give me a thumb up. If you like it, please share and subscribe. See you on the next video. Bye bye.